We all know about binary numbers. They are expressed in terms of zeros and ones. So you can have binary numbers like 110001 or 100011. So what does 110001 mean? It means that the ones and the zeros are multiplied by the respective power of 2's and added to get the equivalent decimal number. 110001 is nothing but 32 plus 16 plus 1, which is equal to 49. Similarly, 100011 is equal to 32 plus 2 plus 1, which is equal to 35. If we add the two binary numbers, we should derive another binary number, and the decimal equivalent of that binary number should be 49 plus 35 equals 84. Similarly, subtracting the second binary number from first one should yield another binary number, and the decimal equivalent should be 49 less 35, which is equal to 14. Let's see how that happens. Firstly, the addition. If we add 10001 and 100011, we first add 1 and 1 on the extreme right, which is equal to binary 10. So we have 0 in the first position and 1 is carried higher up to the second position. For the second position, we now have to add 1 plus 0, which is equal to 1, and then 1 plus 1 is binary 10. Again, we get 0 in the second position, and the 1 is carried higher up to the third position. Thereby, in the third position, we have 1 plus 0 equal to 1, and then 1 plus 0, which is equal to 1. So we get 1 in the third position. In the fourth position, 0 plus 0 is 0. In the fifth position, 1 plus 0 is equal to 1. In the sixth position, we have 1 plus 1 equal to binary 10, so we get 0 in the sixth position and 1 in the seventh position. So the final number is 101010. If we want to understand the mechanism behind the binary addition, let's now add the full expression and see how the powers of 2's are raised to get the binary values. So, in the first term, we have 1 multiplied by 2 to the power of 0 plus 1 multiplied by 2 to the power of 0, which is equal to 2. The expression of 2 in binary term is equal to 1 multiplied by 2 to the power of 1 plus 0 multiplied by 2 to the power of 0. It is as good as putting 0 multiplied by 2 to the power of 0 in the first place and carrying forward 1 multiplied by 2 to the power of 1 to the second place. Now if we add these three terms, we get 4, which is nothing but 1 multiplied by 2 to the power of 2. So we move this term to the third place and put 0 multiplied by 2 to the power of 1 in the second place. If we now add these three terms, we get 4, which is nothing but 1 multiplied by 2 to the power of 2, and hence it goes to the third place. In the fourth place, we have 0 multiplied by 2 to the power of 3 plus 0 multiplied by 2 to the power of 3, which is nothing but 0 multiplied by 2 to the power of 3. In the fifth position, we have 1 multiplied by 2 to the power of 4 plus 0 multiplied by 2 to the power of 4, which is 1 multiplied by 2 to the power of 4. In the sixth position, we have 1 multiplied by 2 to the power of 5 plus 1 multiplied by 2 to the power of 5. This is equal to 1 multiplied by 2 to the power of 6, which moves to the seventh place. We simply write 0 multiplied by 2 to the power of 5 in the sixth place. So the resultant number becomes 0, 0, 1, 0, 1, 0, 1 from first position to seventh position. This is nothing but 64 for the seventh place, plus 16 for the fifth place, plus 4 for the third place, which is equal to 84. This is same as sum of decimal values, which is 49 plus 35. Now let's look at how subtractions work. If we subtract 1,0,0,0,1,1 from 1,1,0,0,0,1, we first subtract 1 minus 1 on the extreme right, which is equal to 0. For the second position, we subtract 1 from 0. Since 0 is less than 1, we borrow the nearest one from higher up, replacing it with 0 and put in the second position in the result. We also convert all preceding zeros to ones. In the third position, we now have 1 minus 0, which is 1. In the fourth position, 1 minus 0, which is 1. In the fifth position, we have 0 minus 0 equal to 0. In the sixth position, we have 1 minus 1, which is equal to 0. So the resultant number is 1110. In order to see how that happens, let's have the respective expressions and see how the powers of 2's are lowered to get the binary values. Now in the first position, 1 multiplied by 2 to the power of 0 minus 1 multiplied by 2 to the power of 0 is 0. This is equivalent to 0 multiplied by 2 to the power of 0, and it goes to the first place. In the second position, we have 0 multiplied by 2 to the power of 1 minus 1 multiplied by 2 to the power of 1, which is minus 1 multiplied by 2 to the power of 1. This is little tricky as we cannot have a negative coefficient of powers of 2's since the expressions are additive in nature in binary numbers. In order to tackle this problem, we need to shift a surplus positive 2 to the power of 1 to the second position, so that the resultant term in second place becomes non-negative. Let's see how to achieve this. We look for the nearest power of 2 with a coefficient of 1. In this case, we have 2 to the power of 4 with 1 as coefficient in the fifth position. This term can be expressed as 2 to the power of 3 plus 2 to the power of 3. Further, 2 to the power of 3 can be expressed as 2 to the power of 2 plus 2 to the power of 2. Same way, we break one of the 2 to the power of 2's into 2 to the power of 1 plus 2 to the power of 1. In this process, the coefficient of largest power of 2, which was 2 to the power of 4, becomes 0 with successive terms with reduced power of 2's with coefficient of 1. Now we substitute the minuend terms with these new terms one by one. Interestingly, in the second position, where we were having a negative number, we now have two ones multiplied by 2 to the power of 1. Thus, the new effective subtraction operation is 1 plus 1 minus 1, which is 1. Therefore, the new subtraction term, instead of minus 1 multiplied by 2 to the power 1, becomes 1 multiplied by 2 to the power of 1, which goes to the second position. In the third position, we have 1 multiplied by 2 to the power of 2 minus 0 multiplied by 2 to the power of 2, which is 1. Similarly, in the fourth position, we have 1 multiplied by 2 to the power 3. In the fifth position, we have 0 minus 0, which is 0. Similarly, in the sixth position, we have 0. The resultant number is 0, 1, 1, 1, 0, 0 from position 1 to position 6. This can also be written as 1, 1, 1, 0, ignoring the zeros on the left. This is nothing but 8 for the fourth place, plus 4 for the third place, plus 2 for the second place, which is equal to 14. This is same as subtraction of equivalent decimal values of 49 minus 35, which is equal to 14. Hope the logic of binary operations are clear with this video. It is important to remember that in addition, the powers of 2's are raised, whereas in subtraction, the powers of 2's are lowered during the operation.